Area of rectangle and square. Let us now understand how to calculate area of a rectangle if the length and breadth are known. When we multiply the length and breadth of a rectangle, we get its area. Area of rectangle is equal to length into breadth is equal to L into B. Similarly, area of a square is equal to length into length is equal to L into L is equal to L square. Variables and constants. In algebra, we use variables and constants. A variable has no fixed value, but a constant has a fixed value. If we write y is equal to x plus 3, then y and x are variables and 3 is a constant. Algebraic expressions. If we add 5 to p, we write the sum as p plus 5. Such an expression is called an algebraic expression. An algebraic expression has variables and constants. Here, p is a variable and 5 is a constant. 13 multiplied by q can be expressed as 13q. Similarly, y divided by 15 can be expressed as y by 15. Here, 13q and y by 15 are algebraic expressions. Solution of an equation. Let us consider an equation. 3x plus 5 equal to 14. This can be written as 3x plus 5 minus 5 equal to 14 minus 5. Subtract 5 from both the sides, or 3x equal to 9, or 3x divided by 3 equal to 9 divided by 3. Divided both the sides by 3, or x is equal to 3. So the value of x is 3. Let us place this value of x in the equation 3x plus 5 equal to 14. 3 into 3 plus 5 is equal to 14. 9 plus 5 is equal to 14. 14 is equal to 14. It means LHS is equal to RHS. The value of a variable which satisfies the given equation is called the solution of the equation. Here, x is equal to 3 is the solution of the equation. Ratio formation. In mathematics, when we compare two different quantities by division, we call it a ratio. For example, when we write 1 by 3, it means we are comparing 1 and 3 by division. In form of ratio, we write 1 by 3 as the ratio of 1 is to 3 and read as ratio of 1 to 3. Here, 1 and 3 are the two terms of 1 to 3. If we multiply or divide the terms of the ratio by the same number, the ratio does not change. For example, ratio of 1 to 3 is same as ratio of 1 into 2 to 3 into 2. That is ratio of 2 to 6. Similarly, 1 divided by 5 to 3 divided by 5 is also same as ratio of 1 to 3. Remember, ratio of 1 to 3 is not same as ratio of 3 to 1. Ratio of 1 to 3 means 1 by 3, but ratio of 3 to 1 means 3 by 1. Proportion. If we take four numbers, when the ratio of the first two numbers is equal to the ratio of the last two numbers, then these four numbers are said to be in proportion. Let us take the numbers 7, 10, 35 and 50. Here these numbers are in proportion because ratio of 7 to 10 is equal to ratio of 35 to 50. In a proportion, the first and the fourth numbers are called extreme terms or extremes, and the middle two terms are called as means. Here, 7 and 50 are extremes and 10 and 35 are means. The important quality of proportion is that product of extremes is equal to product of the means. Here, 7 into 50 is equal to 35 into 10, equal to 350. Hence, these numbers are in proportion. Unitary method. Many a times we buy things in large numbers, like buying 20 oranges and paying the total amount for it. To find out the price of one item, say orange, we have to decide the total cost paid by the number of units purchased. After finding it, we can calculate the amounts for many other units also. This method of calculating the value of one unit and then the value of the required number of units is known as unitary method. Let us take an example. Shivani goes to the market and buys 30 pens for rupees 510. Now, she wants to find the cost for 45 pens. For this, she first calculates the cost of one pen, dividing 510 by 30. She gets 17. This gives her the cost of a pen. So the cost of 45 pens is equal to 45 into 17 rupees, equal to 765 rupees. Symmetrical figures. Let us take a square. Now we fold it in two equal halves in such a way that both the halves overlap or cover each other exactly. Such figures are called symmetrical figures. The first figure is a triangle that can be divided symmetrically like. The second figure can be divided symmetrically like. The third figure is not symmetrical as we cannot divide it into two exact symmetrical halves. The last figure again is symmetrical because we can divide it into two exact symmetrical halves. Lines of symmetry. A line of symmetry is a line which divides a symmetrical shape into two exact symmetrical halves. A symmetrical shape can have one or more lines of symmetry. Some figures can have more than one line of symmetry. The first figure has two lines of symmetry. The circle has infinite lines of symmetry. Reflection. When you look in a mirror, you see your inverted image in the mirror. This image is your reflection in the mirror. Reflection is the laterally inverted image of an object in the mirror. The object and its image together form a symmetrical shape, and the mirror line is the line or axis of symmetry. The reflected image does not have any change in the shape or size. Observe these figures. Here, K is the mirror line, and the portion of the figure on the right side of the line is the image of the left portion of the figure.